Hello, this is Mrs. Ward, and I am going to go over the review packet for sections 2.1 to 2.4. So number one says use the definition of a derivative to calculate the derivative of the function. I know the derivative is 6x minus 5. I can tell that by looking at it. That's not what the question is asking. The question is asking for you to show the work using the definition. So this is when delta x is approaching 0. And that's f of x plus h, or delta x, I should say. And I wrote an h squared minus 5 times x plus delta x plus 7, and then I'm going to subtract f of x, which is at 3x squared minus 5x plus 7, and I'm putting this all over delta x. Remember, the notation is important, so I'm going to keep on writing as delta x approaches 0. Here, I'm going to FOIL this and distribute the 3 at the same time, so I'm going to have 3x squared plus 6x delta x plus 3 delta x squared minus 5x minus 5 delta x plus 7 minus 3x squared plus 5x minus 7. And this is all over delta x. Everything after this minus sign should simplify, so I have negative 7 followed by positive 7. Positive 5x, negative 5x, negative 3x squared, positive 3x squared. Everything that's left should have a delta x in it, so I'm going to take the time to factor out a delta x. And I'm going to have 6x plus 3. That power goes down by 1, so it's going to be 3 plus delta x. And then I am going to have minus 5. And this is all over delta x. Now I can see that the delta x's will simplify because now it's a factor. I'm going to take the limit as delta x approaches 0. 6x, and plus of that, in place of that delta x, I'm going to write 0. And so that means my final answer, or my derivative of this function, is going to be 6x minus 5, which we knew, but that's the work to show it. Part B says find the equation of a tangent line to the graph of f at the point where x is equal to 1. So the first thing I'm going to do is I'm going to find f of 1. So I'm going to go back to that original equation, and I'm going to substitute in 1. So 3x squared minus 5x plus 7, and when I do all this, I get, what do I get? I get 5. So my point is 1, 5, and then I want to find the slope of this line, so now I'm going to find my derivative at the x value of 1, so this will be 6 times 1 minus 5, and so my slope is going to be 1. So doing point slope, y minus 5 is equal to x, or 1 times x minus 1. And so my final equation will be x plus 4. And that's the equation of my tangent line. Moving on to the next one, it says let f of x equal 5x squared minus 2x plus 1. Calculate the derivative and use the results to determine the x-coordinate where f has a horizontal tangent. So to do that, I'm going to first find the derivative, and I'm just going to use the power rule to do that. So this will be 20x to the third minus 4x, and then the derivative of 1 is 0. I want a horizontal tangent line, which means that the derivative is equal to 0. So what I did is I solved this. So the first thing I did is I factored out a 4x and made this 5x squared minus 1. Set both of these equal to 0, so 4x is equal to 0, x is equal to 0. 5x squared minus 1 is equal to 0, so 5x squared is equal to 1. X squared is equal to 1/5. Take the square root, so x is equal to plus or minus 1 over the square root of 5. Of course, I rationalized, so plus or minus the square root of 5 over 1. And I'm going back up. Oh, no, it's over 5. My bad. I'm going back up to check it, and it just wants the x values, so I'm done. If it didn't want the x values, if it wanted the ordered pair or the points, I would have to substitute these back in. Number 3, find the derivative. It's a trig function. I'm going to simplify before I find it because I really don't want to use the quotient rule if I don't have to. So I'm going to think of secant as 1 over cosine I'm going to think of cosecant as 1 over sine. To take care of this division, I'm going to end up multiplying the numerator by the reciprocal of the denominator. And when I do that, I'm going to have sine of x over cosine of x. So I'm going to say f of x is equal to the tangent of x. So all I did was simplify this to get this. I did not have to take the derivative yet. Now I'm going to take the derivative, and the derivative of tangent is going to be secant squared x. And that's it. That's all I have to do. A heck of a lot easier than trying to use the quotient rule. The next one, find the derivative. This is going to be an example of where you use the chain rule. So I am going to do 4 times that quantity, and then reduce the power by 1. So this will now be raised to the third power, and then take the derivative of what's inside, which will be 4x. So when I put together the 4 and the 4x, I'm going to have 16x times the quantity of 2x squared minus 6 to the third power. A couple things. First of all, I'm not going to expand that. I'm going to leave it as 2x squared minus 6. I am not going to go ahead and try and multiply that out. The second thing is I know in this parenthesis I have a 2 in common, but since it's raised to the third power, I'm just going to leave it in there. I can't factor out a 2. I would actually be factoring out an 8, I believe. So I don't want to do that, so I'm just going to leave it the way it is. Number 5, find the derivative. So I'm going to have to use the quotient rule. I cannot simplify this one because I have that 1 plus and 1 minus, so I have to go with what I have. So to find the derivative, I'm going to leave my denominator alone. I'm going to take the derivative of my numerator. Well, the derivative of 1 is 0. The derivative of sine of x is cosine of x. Minus, now I'm going to leave the numerator alone. So 1 plus sine x I'm leaving alone. Taking the derivative of the denominator, I'm going to have 1, which is the derivative of that is 0. Then I'm going to have that negative sign, and the derivative of sine of x is going to be cosine of x. And this is going to be all over 1 minus sine x squared. Well, I'm going to go ahead and distribute this cosine x, and I'm going to have cosine x minus cosine x sine x minus, distributing this negative cosine x, I'm going to have a negative times a negative, we'll make that a positive. So I'll have cosine x plus cosine x sine x, and this is all over 1 minus sine x squared. When I look at the numerator, I see that I have a negative cosine x and a positive cosine x, so those are opposites, so they will add to 0. I have 2 cosine x's, and then this is technically 1 minus sine x times 1 minus sine x. So I'm just going to leave it as 1 minus sine x squared. I'm not going to try and simplify that, and that is my derivative. Number 6, find the derivative. It looks complicated, but since I'm not multiplying anything or really dividing anything, I'm just going to find the derivative term by term. Before I start that, though, I might want to take the time to rewrite this 2 over x as 2 times x to the negative 1, and that way I don't have to deal with the quotient rule. I'm going term by term, so the derivative of 3 cosine x will be negative 3 sine x, because the derivative of cosine x is negative sine x. Then the derivative of negative 3x squared will be negative 6x, and the derivative of 2x negative 1 will be minus negative 2x to the negative 2. The only thing I have to do to rewrite this is I am going to take care of that negative exponent, and I'm going to make this minus 2 over x squared. Remember that negative exponent only goes to the x. It does not go to the 2. The 2 stays in the numerator. Okay, number 7, now I have to use the product rule and the chain rule, it looks like. So when I find the derivative, I'm going to leave my first parenthesis alone. Taking the derivative of cosine, which would be negative sine pi x, and then taking the derivative of what's inside, and remember that pi is a constant, so that derivative is going to be pi. Then I'm going to have plus, and now I'm taking the derivative of the first parenthesis, which will be 3x squared minus 4x, and then I'm leaving that cosine pi x alone. I think all I'm going to do is bring this pi up front, and I might factor out an x squared here. So I'm going to have pi x squared times x minus 2. Oh, negative. There's that negative sign. I'm going to factor that out too. Sine pi x, and I already brought that pi up. And then I'm going to have plus 3x squared minus 4x times cosine pi x. And I just left it like that. I guess here I could make that x times 3x minus 4. I guess I could factor out an x from the whole thing. Yeah. Okay, moving on to the next one. This is actually, you can think of it as sine of x cubed plus 2x squared, and this whole thing is being raised to the 5th power. So when I go to find the derivative, I'm going to take care of something being raised to the 5th power first. So 5 times that sine x to the 3rd plus 2x squared. We can reduce the power by 1, so that's going to be 4. Now I'm taking the derivative of what's inside. The derivative of sine is cosine, so this will be cosine x cubed plus 2x squared, and that's always going to be raised to the 1st power because you're just taking the derivative of sine. It has nothing to do with that exponent. And now I'm taking the derivative of what's inside, so this will be 3x squared plus 4x. And then I could leave it like that. I can't factor anything out. I mean, most of the times they bring this up front. So I think that's just a visual preference. Oh, I could factor out an x, so let's factor out that x. And that's it. Okay, the next one, I'm thinking of this as 2x squared. That's one factor. And then x squared minus 2 raised to the 1/2 power. I'm going to have to use the chain rule and the product rule. So to find the derivative, I'm going to leave the first term alone. Take the derivative of the second term, so that's going to be 1/2 times x squared minus 2. Reduce that power by 1, so that'll be negative 1/2. Take the derivative of what's inside, and that'll be 2x. Plus, now I'm going to take the derivative of this 2x squared, which will be 4x. And then I'm leaving that x squared minus 2 raised to 1/2 power alone. I'm going to multiply what I can. So here, the 2 and the 1/2 will simplify. But I'm still left with this 2x times x. So this will be 2x to the 3rd times x squared minus 2 raised to negative 1/2 plus 4x times x squared minus 2 raised to positive 1/2. So I am going to factor out an x and a 2. So 2x. And then I'm going to factor out this quantity of x squared minus 2. The lowest power I see is negative 1/2. So from the first term, I'm going to have to multiply by x squared to get that 2x to the 3rd. And then I've already factored that out. From the second term, I'd have to multiply 2x by 2. And then I'd have to multiply this by x squared minus 2. So that when I add the 1 plus the negative 1/2, that will give me back to this 1/2. So I'm going to try, well, let's do that cheap method of mine. So here I'm going to have, this will be 2x squared minus 4. So I'm going to end up with 2x times 3x squared minus 4. And this is going to be all over because of that negative exponent. I'm going to move it to the denominator, 1/2. And I believe that is my final answer. The next question is asking you if f of 3 is equal to 5. All that means is my x is equal to 3, my y is equal to 5. And the derivative at 3, which in other words, my slope is equal to 3. No, my slope at 3 is equal to -2. Find the equation of the tangent line. So they gave me a point, they gave me the slope. I should be able to put in point slope and find the equation of that tangent line. So when I do that, I'm going to have -2x plus 6 plus 5 plus 11. And that's the equation of my tangent line. Number 11, find the equations of the tangent lines to the graph of f of x is equal to 4x minus x squared that passes through the point 2,5 that is not on the line, the graph, it should say the graph, because that is a parabola. So I'm just going to sketch what I think is going on. I have a parabola that opens down. I have this point up here. Let's call this point 2,5. I'm going to have two tangent lines. I'm going to have one here. I'm going to have one here. So I have this point here, which I'm going to call xy. I have this point here, which I can also call xy. Obviously, they're not the same x, they're not the same y. And it wants the equation of those two tangent lines. So the first thing I'm going to do is I'm going to find the slope of the curve. So to find the slope of the curve, I'm going to find the derivative of f of x, which is just going to be 4 minus 2x. Then I'm going to find the slope between the point 2,5 and some point xy. So I'm going to do the difference of the y's, so y minus 5 over x minus 2. And I'm going to set that to this slope because they have to be the same. If it's a point here, the tangent line has to have the same slope as the slope between those 2 points. So when I do this, I am going to multiply both sides by x minus 2. To get that x minus 2 out of the denominator, I'm going to have y minus 5 is equal to, and when I FOIL this, I get -2x squared plus 8x minus 8. Set it equal to y, so I'm going to add 5. Add 5 minus 3. All right, so what that means is I have this other parabola, which I'm going to draw very poorly, that goes like this, that goes through those 2 points. And so now I need to find the intersection of these two parabolas, so I need to solve the system. I'm going to solve it by substitution because remember, this is y. So I'm going to take this 4x minus x squared, and I'm going to put it in for this y, and I'm going to solve. Okay, I have this thing about negative lead coefficients, so I'm going to bring everything over here. So I'm going to have x squared minus 8x, and then bring the 3 over, and this is 4x. Oh my, I really messed that up. So this would be minus 4x, and then plus 3 is equal to 0. Now I'm going to solve that, probably going to factor it. I'm going to do x minus 3, x minus 1 is equal to 0. They add up to -4, the product's 3. So x is equal to 3, x is equal to 1. So I found the x coordinates. So like this point will be 1 something, this point will be 3 something. Let's find the y's first. I'm going to find the y's by finding f of 1. So that'll be 4 times 1 minus 1 squared. And when I do that, I have 4 minus 1, and I believe I get 3. So my ordered pair is going to be 1, 3. Then now I'm going to find f of, that was 1, and then find f of 3, which will be 4 times 3 minus 3 squared. So 12 minus 9, that's 3. So that ordered pair is going to be 3, 3. Give me 1 second. Okay, so now that I have those 2 points, I need to find the slope. So I can either put the slope into this formula or I can put into the derivative. I'm going to choose to put into the derivative. So the slope at 1 is going to be that 4 minus 2x So 4 minus 2 times 1. So that slope is going to be 2. The slope at 3 is going to be 4 minus 2 times 3. So 4 minus 6, which will be negative 2. So 1 point, I'm going to have the point 1, 3 has a slope of 2. The point 3, 3 has a slope of negative 2. So now I'm going to do y minus 3 is equal to 2 times x minus 1. So y is equal to 2x plus 1. And this one is going to be y minus 3 is equal to negative 2 times x minus 3. So y is equal to negative 2x plus 9. And then I thought I'd show you what that looks like on the calculator. So what I did is I graphed my original equation way up here. I graphed the 4 minus x squared. And here's a graph of 4 minus x squared. Then what I did is when we solved here and we got down here and we found this equation here, remember that's some type of parabola that has the two places that intersect that have a tangent line through 2, 5. So I went ahead and I graphed that one. So let me show you that one. And that's that parabola here. And here you can see it's intersecting at two places. And those two places ended up being that point 1,3 and that other point 3,3, which you can see here from the graph. Then when I found my tangent lines, I thought, well, let's check them and make sure they're right. So here's the first tangent line, that 2x plus 1. And you can see, if I look here, it goes through that point 1,3, and it looks like if I were to go to 1, 2, 1, 2, 3, 4, 5, it will go through that point 2,5. And then I did the other tangent line, which was that 2x plus 9. I'll turn that one on. And so here, blue is the original graph. The red parabola is the place that meets the criteria of going through the point 2,5 that has tangent lines on the graph. And then the black line and the pink line are going through that point 2,5, and they're both tangent to that to a point on the original graph. So that's what it looks like, and that's what you're doing. And I hope that might help. Yeah, I'm sure you'll let me know. All right, the next one, find the instantaneous rate of change. All I want you to do is find the derivative and substitute that value in. So I am going to find the derivative of s of t, and it'll end up being 6t plus 1. Then I'm going to evaluate when t is equal to 7. So I'm going to have 6 times 7 plus 1, so 42 plus 1, 43. If I don't give you units, you can't answer with units back. Next one, find the derivative if f of x is equal to that. I just want to see if you can rewrite it, x to the 1/2 plus x to the 4/5. So when I find the derivative, I'm going to have 1/2 x to the negative 1/2 plus 4/5 x to the negative 1/5, because 4/5 minus 1 would be negative 1/5. Writing it without a negative exponent, I'm going to have 1 over 2x to the 1/2 plus 4 over 5x to the 1/5. So make sure you know that that negative only goes to the x and not to the entire fraction. Find the derivative, and this one I'm using the product rule within the chain rule. The chain rule within the product rule, I guess I should say. So to do this one, I am going to leave the first parenthesis alone. And I see that there's a 3 there in common. I'm not going to worry about that 3. I'm not going to try and factor it out. I'm just going to live with it. Then I'm going to have 4 times x to the third minus 7. Reduce that power by 1, so this will now be raised to the third power. Find the derivative of what's inside, and that'll be 3x squared. Plus, now I'm taking the derivative of this first one, so it's going to be, I'm going to write down here, 5 times 3x squared plus 3, reduce that power by 1, so that'll be to the fourth. Take the derivative of what's inside, so that'll be 6x. Leave the second parenthesis alone. Then when I go to simplify this, the two quantities that I have, that I know are going to factor out, is this 3x plus 3x squared plus 3. And then the other one is going to be this x to the third minus 7. I'm only going to worry about factoring these two out now. I'll factor everything out later. So when I do that, factoring out. I'm factoring out this 3x squared plus 3. I have 1 to the 5th power, 1 to the 4th power, so I'm going to factor out the lowest power, which is 4. Then I have that x to the 3rd minus 7. 1 to the 3rd power, 1 to the 4th power. I'm going to factor out the lowest power, which is 3. Here's my bracket. This is my first term. This here. So I'm looking at that and I'm asking myself, what have I... So I have 3x squared plus 3 to the 5th. I only factored it out to the 4th, so I'm going to need one of those. And then I have this 4. I should have put that in front, but I did not. I'll live with it. Oh. Let's not do that. I have this 4, and I have this 3x squared, so I'm going to make that 12x squared. Okay, now I feel better about that. Here's the plus sign. I have this 5, and I have this 6x, so I have 30x, and 3x squared plus 3 to the 4th, 3x squared plus 3 to the 4th, already taken care of, and then I factored on x to the 3rd minus 7 to the 3rd. This is to the 4th, so I'm going to need one of those, x to the 3rd minus 7, just one of those. Okay, now I'm leaving this first two parentheses alone. Well, no, I changed my mind. Here I have a 12x squared, and here I have a 30x squared, so I'm going to factor out a 6x. I'm going to bring that 6x up here. 3x squared. If I factor out 6x, I'm going to be left with 2x times 3x squared plus 3. And if I factor out 6x, I'm going to be left with 5 times x to the 3rd minus 7. So this will be 6x to the 3rd plus 6x plus 5x to the 3rd minus 35. So when I combine my like terms, I'm going to have 11x to the 3rd plus 6x minus 35. Nothing can simplify. It cannot factor, so I'm just going to leave it like that. And then this whole thing is my derivative. Oh, that's it. We're done. So I hope this helps, and I'll see you next time in class.